First of all, thank you all for joining. There's a QR code showing on the screen right now. If you want to snap a picture of that and do the survey, then you can get some free swag at the Microsoft booth. And I will be there, so if you want to chat afterwards, then I'm very happy to meet you there. So thank you for coming to the sponsored talk. Today, what I will be talking about is what Microsoft is doing to push PostgreSQL forward in terms of what we are contributing, both to the open source project and what we are building on top of the open source project, because we, of course, have products built on PostgreSQL, but we want you to understand the bigger picture. And not all contributions are code. Some of them are events like this, which we happen to also sponsor, but there are events that we participate in magnitude. So there's this line in the middle of the screen of the list of various PostgreSQL conferences. And the conferences above the line are those that we either organize, co-host, or in some way participate. So for example, POSET is an online conference fully organized by Microsoft, but in other conferences we may have, for example, people on the talk selection committee or on the organizing team, or in some way we are participating with our employees in the making or creation of the event. And the below ones are those that we funded or participated in, had talks in, etc. So there's a lot that we do in terms of participating in the community. We see ourselves as part of it. A lot of us come to Microsoft from the PostgreSQL community in the first place. So I mentioned POSET. POSET is an event that we host for 4 years in a row now. This year, we had 230 talk submissions, which is a 25% increase over the last year. And the previous event had 42,000 views after the event, because all talks on POSET are actually recorded. They are all available online. You can watch them even today. And it's a great event for first-time speakers or for people that are not able to travel to places like this one and still want to participate in an online event. So the way POSET works is it has a hallway track of its own where you can talk with both the speakers and other participants during the event timeline. And as for the next POSET, it's happening in 2026. You can save the date, June 16th, June 18th. And if you're thinking about submitting your talks, especially if you're a first-time speaker, maybe you've never done this before, this is a good place to start. We are very open for first-time speakers. We will open the call for papers in the middle of November. So that's where you want to look into submitting. And I maybe didn't expand the name. If I can go back for a second, that's Postgres Open Source Ecosystem Talks, Trainings, and Education is what the name expands to. And maybe you have heard the previous name. The previous name was CitusCon, because this is an event that first was a Citus online conference, but we wanted to make it broader and more around PostgreSQL itself, not only because we were always open into different talks, but people seeing the name were thinking that it's Citus only, and we wanted to be broader. And speaking of that, and other names that you may have heard, there's this podcast that we do about PostgreSQL. It used to be called Path to CitusCon, and it originated as an idea that, okay, we have this time between the CFP, the talks selected, the speakers selected, and the event itself. What would be a fun thing to do? And we decided that we could do a series of interviews with our speakers leading up to the event itself, and that's how Talking Postgres evolved. And it's now a regular event that we do with multiple speakers from the community, like Tom Lane, Andres Freund, Melanie Plageman, Bruce Moninjan, Robert Haas, and many others that you probably know and meet in the hallways of this great event. So what this talk is built on top of an annual blog post that a colleague of mine, Claire Certiano, that you can also meet here at the Microsoft booth and in other places at the conference, does on an annual basis, that goes into the detail of everything that Microsoft does around PostgreSQL, from open source to conferences to things we build. So if you want details, like if I'm skipping something, or if you find something very interesting and you want to find the actual commit or diff that's being mentioned, this is the blog post you want to go to and find the nitty-gritty details. So first we will focus on the first section of contributions, which is contributions to the actual PostgreSQL core. And Microsoft contributes in multiple ways. We actually have a team of committers that are mostly focusing on contributing upstream, and all other employees also contribute directly or indirectly to the project with code and with talks and with other events. Some of the big ones are obviously asynchronous I/O. We will get into those in a bit. So speaking of, we have 7 committers currently employed by Microsoft out of 31 total in PostgreSQL, and 90 Postgres open source contributors employed by Microsoft in general. And if you look at PostgreSQL 18 that released recently, we can look at some of the statistical numbers of contributions, and let's first define what are outer commits. So here we are not talking about commit count. We are talking about the number of people that are credited for every commit, right? So there might be a change made to the code base, and that change may have been co-authored by 2 people. That would be counted as 2 here, not as a 1 commit. And that also applies to things done outside of Microsoft. So when you look at the 3,320, that's not a count of commits, that's also attributing other people outside of Microsoft that may have co-authored multiple patches with other people. So for 540 commits are attributed directly to Microsoft employees out of the PG18 release, and that's out of the 3,320 attributions in total. Now, if you work with open source, and I assume that many of you here do, you know that sometimes it's as hard to get people to review your changes as it is to write them in the first place, and sometimes it's even harder to get people to look at it and push things forward. So what we also try to do is as employees, we actually participate in the review process, and you can see that in PG18, 18% of the features were reviewed by Microsoft contributors, so that's almost 1,000 out of over 5,000 reviews for the PG18 release. So some of the bigger contributions that I think are worth mentioning are obviously Async I/O, and I hope that you have all seen Andreas' talk. I hoped that it would be after mine so that I could advertise it, but I think it doesn't need advertisement that much because it draws by the sheer topic. But we also contributed things like the OAuth infrastructure, amortization of aggressive vacuum cost, faster database cloning, reducing planning times for partition tables, etc. So I think the most obvious one is Async I/O. So this is a multi-versioned investment to add this complex feature. So this didn't take one PostgreSQL release. It's obviously not only people at Microsoft that are participating in this, but with PG18, we have new significant infrastructure that allows efficient file system I/O with modern operating system features. So all streams, like all read streams now with PG18, use true Async I/O with native I/O uring on Linux or portable worker processes in other places where this is not available. And in the future, writes will also benefit from those changes. So the chart that you see shows relative performance of PG18 using both local and cloud storage. And it's relative to PG17, which is with a baseline of 1, which is here effectively the y-axis. So you may know Thomas Munro, who's a hacker, PostgreSQL hacker at Microsoft. He contributes a lot. There's a quote from him on Async.io. I won't read it because you can all read it in your own time. This is recorded. But I think it highlights some of the great advancements that can be benefited from Async.io. And I said this is like a multi-versioned investment. I know this is very tiny, but I don't think you need to, I will explain what we see, and I hope that it will be okay. So until PG17, when you did, for example, a sequential scan of a table, PG would read data off disk in 8 kilobyte pages in a sequential form. So you can see I hope you can see the highlighted in red are, each line is a system call, and each system call is a read of roughly 8 kilobytes of data from disk. With PG17, so the previous PostgreSQL release, you had I/O combining, and that allows those sequential reads using the read stream interface. And in that way, you can use a vector read where you can consume multiple 8K pages at the same time. So the figure shows the same SQL being executed on a newer PostgreSQL version, but resulting in much less I/O system calls because the pages can be concatenated and read in batches. So that greatly reduces the I/O consumption. So there is going back to the podcast, right? There is a recent podcast that you can watch by Andres Freund on the Async.io subsystem that will go into many more details of interesting things that went right and wrong with this feature. So I highly encourage you to take a listen of that. So some of the other contributions in this release in PG18 is optimizations for memory management for materialized view, Windows aggregations, and common table expressions. We have reduced planning times for partition tables with many partitions. More on that a bit later. We prefactored the executor to allow inlining of logic with fastpath locking improvements. And there have been speed-ups in group by and hash joins and removal of redundant group by columns using unique indexes. So some of the yet additional contributions are things like the OAuth infrastructure. So before, you weren't able to use any form of OAuth with PostgreSQL. And Microsoft contributed code to allow using secure token-based authentication from security providers. And that's explicitly not only Microsoft security providers, you can use other security providers for this feature. And regarding table partitioning, we learn from our customers, and that informs us where to, so our customers on Azure, with their practical performance issues, indicate where we should be spending time upstream with PostgreSQL. And that's a real life feedback that can benefit everyone. So in this case, we had a customer having problems with table partitioning that we worked with and learned from, and co-authored patches in PG18. And based on those learnings, we improved performance for essentially everyone using table partitioning. And that's with initial benchmarks of using around 56 partitions showed that the planner, after those changes, is 3 times faster. And in a scenario of thousands of partitions or more, the improvement is even more significant in the planning time scene. And of course, like there are the other mentioned changes, like improvements of impact of aggressive vacuums by eagerly scanning pages during regular vacuum with more efficiency. There's also early groundwork on multi-threading, and that's a favorite topic of mine after I digged up this pretty old but fantastic paper, the implementation of PostgreSQL from 1990 by Stonebaker, Roy, and Hirohama. And in it, we can read that the current implementation, where every process, every connection is a separate operating system process, is just a quick hack to get PostgreSQL running, and it will be soon changed into lightweight processes available in operating systems. So that was in 1990. We are still not there. I think it will take us, hopefully, not as long to get there, but there's some early groundwork done in that. And this is a very hard topic because after years of running with process-based like connection per process model, you have assumptions about things like memory usage, that it's simply returned to the operating system when the process finishes execution. And those are changes that will no longer be the case if you introduce multi-threading. There are locking and other things that need changes. And the early groundwork, if my memory serves me well, was around locale support and making sure that multi-threading with locale is done properly. And apart from PostgreSQL, we built tooling for PostgreSQL. So if you are using VS Code, there's been a new extension deployed, announced at Build this year. And we will go over a very brief list of its features. There's a bunch of quotes on it, and it's over 200,000 installs right now. And a significant set of functionality where you can create local databases, visualize schemas, have query editors running PSQL locally, etc. And I will go over some of these in the next slides. So this is the extensions installed. This is a very small GIF that will go in a loop. But it's essentially showing you that you can use the extension directly and connect to a PostgreSQL instance, in this case on Azure, where it will, given a subscription ID, filter out all the available instances and allow you to easily connect using something like Entra ID without providing additional credentials. But this is also, and we swapped the slide if it's not apparent, but this is also possible to be used with any other PostgreSQL instance. So in this case, we are connecting to a local Docker container, and that can be as well a remotely deployed physical machine or a virtual machine or even a different cloud provider. So it's essentially a tool you can use with any PostgreSQL instance. I mentioned that we have a structured view of what's available in the system, so you can see the tables. You have normal hierarchical browsing of your database. And one of my favorite features is the schema visualization, which essentially allows you to quickly see, just a sec, sorry, misclick. Which allows you to very easily see how your schema looks like, and that, it helps me to visually see what I'm working with when I'm trying to understand how a query works. So that's something that I've been missing, or it would require additional tooling or something that essentially requires too much setup for me to ever bother. So I'm very happy to see this right now. And on top of that, you have query editing with content-aware IntelliSense, which knows your SQL keywords, table names, and functions, and has syntax highlighting and auto-formatting for improved query readability. And it also tracks the history of previous queries so that you can reuse them easily. Now, like with everything, there's Copilot in it. So you can use it to explain your queries. You can ask it questions like, hey, what is this query doing? And it will give you an answer of like what are the tables involved, why, etc. This is a AI assistant that's directly within VS Code. It simplifies interactions using natural language. You can use commands as PGSQL to allow to allow it to query databases, optimize schemas, and execute SQL operations with these. We saw the explain query. You can also tell it to rewrite a query or analyze a query for performance. And it can give you like real-time expert-level advice on getting your PostgreSQL performant, and that improves the ease of entering for new people into the project. So here's an example of the chat agent that goes beyond the simple question and answer. I know it's fairly small, but I will explain what it's doing. So in this example, we ask the agent to create a new database on a specific server in my saved connections on the left and enable the PostGIS extension. And it is able to figure out where to connect and what to do. And the agent begins by listing the server connections, connecting to the PostGIS server, drafts the script to modify the database, and finally it waits for permission to do the execution before continuing. So there are no modifications that you do not approve explicitly. So going back to the service that we are running, we of course run PostgreSQL as a service. So we take the open source release that we also contribute to, and we deploy it and manage it for our customers on Azure, making some things simpler because you don't have to set them up and monitor them. But also we build new features on top of it. Some of those you may know. So for example, Elastic Clusters is built using the Citus extension. So we are still heavily investing in Citus and seeing the future with Citus. Currently we have 3 products consuming directly from Citus, which is Cosmos DB for PostgreSQL, Elastic Clusters that we will GA at Ignite in less than a month, and Cosmos DB for Mongo vCore, which is actually Mongo on top of Citus. So there's heavy usage. In recent Citus releases, we added support for PG17, which is what we will GA with Elastic Clusters, and we are currently working on PG18 support. Citus 13.2 comes with some very nice improvements that are also driven by our needs for our customers, which is like, for example, snapshot-based node addition, which means that you can add a new node to the cluster and not rebalance, but instead add that node based on an existing disk snapshot, and then tell Citus to drop the data that would normally be moved around. So you have a much faster operation without network data moves between the nodes. We also did many improvements for query execution performance, most notably for local query execution. So if a query goes to a node that happens to have the data, that execution is much faster now. For Elastic Clusters, since we are bringing Citus to Flexible Server has over 70 extensions. So we spent a lot of time actually going through every one of those extensions and checking their compatibility with Citus, documenting that and publishing that in the Citus open source repository. So you can go there and see what works with Citus, what doesn't, and what are the caveats, because some things are obviously incompatible, unfortunately. For example, timescale DB, because we both hook very low level into the PostgreSQL planner and other places, and we are conflicting in that way. That's not deliberate. But in other cases, it might not be that obvious. For example, if you use something like PG prepack, it wants to do triggers we don't support triggers on distributed tables, but if you do it on a normal table, everything will work as expected. Even if we started supporting triggers, would the extension be cluster aware, right? Like, would it know what it means to replace a table on Citus? And those are the things that we, like the level of detail that we went into to check this, and we plan to maintain this list and keep it up to date as we add new extensions to Flex, as we do new releases of Citus, and we think this not only benefits us, but also anybody else that would like to evaluate Citus for their workflows. Some of the other things that we do is we made query from any node by default. We introduced some new ports for load balancing onto every node in the cluster. And like I mentioned, we go with this GA at Ignite. On Azure, you also have the ability to use DiskKNN. So DiskKNN is the state-of-the-art vector indexing algorithm developed by Microsoft Research and available in Azure Database for PostgreSQL. It offers exceptional performance and accuracy for similarity search tasks, making it a great choice for high-scale generative AI applications. It significantly outperforms traditional vector indexing methods, such as HNSW and IVF flat, both in query latency and accuracy. So in our testing, we found that it outperforms HNSW on common workloads while maintaining higher transactions per second and using less memory. And we recently added a new feature called product quantization, PQ for short. And it's one of the key innovations behind DiskKNN performance, which compresses high-dimensional vectors into compact representations, significantly reduces the memory footprint by fitting more into the same memory. It minimizes the I/O operations and enhances the overall throughput that you can achieve. So it allows for efficient approximate nearest neighbor search with minimum accuracy degradations. And whether you build RAG pipelines with these recommendation systems or like semantic search or personalization engines, you can now leverage this directly on Azure. Going further, we are introducing semantic operators that leverage large language models to add a semantic understanding of operational data. So the four that you can see here, the Azure AI Generate being the most generic operator, is able to perform arbitrary ChatGPT-style generations. For example, you can use it as a column in your select statement to generate a description based on a title of an item that you're just creating. And this is, for example, very useful if you're doing benchmarking on it or any form of testing, or maybe a POC type website and want to fill it with some sensible content. The is-true operator can allow you to do semantic filtering, to do conditions and joins in natural language. So some of this, like one example usage would be you can pass it a comment and a product name, and you can say, does this comment talk about this product, right? And replace both with a variable, and you get an answer, yes or no. The extract operator can extract hidden relationships in your data, and the rank is used for re-ranking your search results. Now we know it's a lot of things are moving fast, and there's a lot of new concepts. So we also have people coming from different databases. So we developed some repositories with examples that you can use. And I'm going to show 3 of those here, briefly talk about them. So the first one is the Agentic Shop, which is a modern retail experience powered by multi-agent orchestration. It uses the Llama index, mem0, pgvector, DiskKNN, and semantic operators to deliver a dynamic and personalized shopping experience, where each shopper gets custom layouts and AI-created content with memory of your prior interactions, driving smarter recommendations as you go on. So this is like a great example on how to build the agentic systems on PostgreSQL. The second one is build your own advanced copilot. So this is like a deep dive into building intelligent copilots using retrieval augmented generation. It uses vector search, semantic re-ranking, LangChain, GraphRag to deliver content-rich answers using structured and unstructured data such as statements of work or, for example, invoices. It uses GraphRag powered by the Apache H extension for complex knowledge grounding, and it's backed by, and is also backed by a practical hands-on lab to guide you on how to learn to deploy faster. And the final one is chat with your data, which is like a natural language interface to your data using Azure OpenAI. It supports flexible resource rack configuration, resource augmented retrieval through prompt engineering, which is like a great starting point to have teams experiment with the concept itself. And finally, we have autonomous index tuning, which is a fairly new feature on Azure. So I don't think like in this audience I need to explain very much why indexes are an important thing in databases, but for the sake of a very brief sake, they are there to enhance performance. They are essential for efficient database operations, and by allowing the database to quickly locate the data without having to scan every row in the table, they greatly improve performance. That's like the very, very brief of why you want indexes for your queries. So what is index tuning? Index tuning essentially analyzes your workloads on Azure and makes suggestions based on that analysis. And those suggestions can be what indexes should be created for your workload, what indexes are unused and maybe should be dropped, what are the duplicate indexes, so like if you have covering indexes that already serve the other index's purpose and both are in use, then it would suggest which ones could be dropped, and invalid indexes. So the way this works is you have an interval of executions that look at your workload as it's changing. So in this example, we have index tuning enabled, and we have 10 recommendations that have been decided upon the previous executions of your workload. And out of those, you can see for every one of them, review the recommendations, what to do with them, and the predicted improvement in performance and impact on size, so from dropping or creating the index. If you go into any of the recommendations, you see a list of queries that are affected by this recommendation. And for a recommendation to show up by default, it needs to at least improve a single query in 20%. So at least a single query needs to see a 20% improvement. And now no queries can see more than a 10% regression as a result of this change proposed. So the expected behavior of this is, of course, that if you're getting good recommendations and you're acting on them, you should see a drop in your CPU utilization, temporary files, and typical increase in transactions per second for your system. So what I want you to take away from this talk mostly is that Microsoft is heavily committed and committing in PostgreSQL in the long term. We are bringing new advancements both to the open source PostgreSQL based on the needs that we see, like the asynchronous I/O subsystem and other work that's multi-versioned. And we essentially want to be the best place to run PostgreSQL. So we want you to believe that if I don't want to host my own PostgreSQL, Azure is a good place to go and host PostgreSQL because they understand how to build with PostgreSQL. So we have socks and swag at our booth. I hope that many of you got them. We still have some time left, so if there are questions, I'm happy to chat.
Is the index advisor something that you're going to do in open source, or is it closed source, or is it Azure only? What's the story there?
So right now it's an Azure only feature. I haven't heard of any plans of opening that up. So I cannot answer that question right now. But I'm going to take this as that would be interesting to see. Okay.
Hi, thank you for the talk. I have a quick question. I saw that you have in DiskINN the support of 16K dimensions in vectors.
Again, please.
You have in one of your slides
Yes.
in regarding DiskINN. Maybe I saw that quickly, but it's.
Yes, I'm going back. One sec. Product quantization.
Before that, yeah, this one. You support up to 16K dimensions. That's a known limitation in PG vector because it's bound to the page model of PostgreSQL, which is normally 4K. How did you end up with 16K? I guess maybe you are not the
I'm probably not the best person to answer that, but I would assume that it's related to product quantization.
Okay.
But I'm not a good person to answer this, so I will mislead you. And I can get you in touch with the people that can answer this. So if you approach me after the talk and give me a contact, then I will get you in touch over email.
And also you didn't mention Query Store for the tuning on Azure.
Yes, I didn't. That's true. Because Query Store is there for a long time, and I was thinking about new developments. Yes, we have Query Store. Query Store is essentially the equivalent of pgstat statements captured over time with some additional things like weight sampling. Is there a question about Query Store? I would say it's partly related. There's a lot that we do at with automated tuning. Like indexes are one thing. In past conferences, we also announced like previews for things like autonomous parameter tuning, which allows you to do the same with PostgreSQL with system parameters, where you decide can it be intrusive or not? Like, can it restart your PostgreSQL instance, or can it only tune runnable parameters? I would say it's the same umbrella of features under Azure. So while they may feed into one another, or they may be completely parallel into each other, right? But it's an area where we would want to go into more automation and suggestions for our customers, because we see very broad range of customers. Some come with extreme experience and desire to change everything and every parameter, sometimes to the point where we don't want to do that for the sake of stability of the platform. But in other cases, we see new people that are doing this because in the past they wouldn't, or they are coming from completely different databases, and they are only now building their experience with PostgreSQL, and they are looking for that guided help on what to change, how to tune, or what's a good practice in Postgres.
Do you mean that Microsoft will support two databases, SQL Server and PostgreSQL?
So I'm in the PostgreSQL team, so I cannot tell for the SQL Server. As far as I know, it's a fully supported Microsoft product, so it will be supported. Like the question is, do we plan to keep both?
My question is Microsoft prioritize PostgreSQL? instead?
Do we prioritize?
Yes.
So those are separate teams, completely separate teams, right? So it's not the same set of people working on PostgreSQL as SQL Server. I would say Microsoft always has the intention of going where developers are, and we see a lot of people that are interested in adopting PostgreSQL, both from existing databases and both people new to the project. So in that sense, Microsoft, as you can see by the presence on this conference, by the talks by people at Microsoft, is heavily investing in PostgreSQL in various forms. But I cannot say to what extent you would prioritize PostgreSQL over SQL Server, because those are like completely separate parallel things. I think we are a big enough organization to work on both things.
Hi, thanks. So on the VS Code extension, what
Yes?
is there plans to support OAuth 2 and Kerberos?
I don't know, but again, I can get you in touch with the person that runs this project.
Okay, cool, thanks. And then on the agent side, in the optimization, does that recommend indexes?
That's a good question. I would expect that the explain performance one does.
Okay, brilliant, thank you.
Any other questions, please? Well, thank you then.
Thank you.